Hello, my name is Thomas Davidson. I'm here today to talk to you about our paper about distributed tracing visualization, which was a qualitative interview study, but we are mainly going to focus on the second half of the title, which is challenges and opportunities for viz research in distributed tracing visualization. This is work that I carried out whilst I was a PhD student at Max Planck Institute for Software Systems under the supervision of Jonathan Mace, and I'm now based at the Emory University working with Professor Emily Wall. So to give you some background, we're going to start off by talking about what actually is distributed tracing. So distributed tracing is a way of monitoring distributed applications, such as those built with a popular microservices architecture. So in a single machine system, people would historically use tools like logging and metrics to keep track of what's going on in the system. However, in modern distributed applications, we have a lot of separate physical machines, and each of these have their own logging and metrics. And requests in these systems can touch multiple machines, and the dispersed nature of them means that it can be really hard to troubleshoot these problems. So distributed tracing emerged as a new kind of tool for troubleshooting these systems. The way distributed tracing works is that the data about the route a request is taken and other relevant metrics is recorded as the request is made. This is then collected centrally, and the data is available for analyzing the application's end-to-end behavior. This kind of monitoring and analytics is commonplace at large internet companies such as Google, Amazon, Alibaba, and Meta. And at these companies, tracing can produce billions of traces per day. And what we're interested in is what happens next. After you've recorded all this data, how do human users actually interact with it? So for a last bit of context here, this is a really brief overview of some of the existing visualization solutions. On the left is a typical textual representation of a trace, and on the right is the most prevalent way of visualizing these traces, called the swim lane visualization. And the specific example is from the open source tool Jaeger, but the swim lane viz is pretty ubiquitous among all the tools that we actually looked at. And you also see this kind of viz in other areas of systems work, such as profiling or high performance computing. So in our visualization, the x-axis here represents time, and each colored bar is a unit of execution, which we'll refer to as a span. And each row is a different service, and in a distributed system, these services will often sit on different machines. So basically, if we think back to our system architecture, each row, give or take, represents one of these physical machines. And the parent and child relationships are inherently indicated by the hierarchy on the left-hand side. So now you've got at least a very vague idea of what distributed tracing is, let's have a look at the problem we're trying to address. So this is a conversation that my supervisor and I had at the start of my PhD, and it might be a very familiar conversation for lots of people, but it is especially true in the field of distributed tracing. And what it really encapsulates is this idea that distributed tracing is a really useful tool. There hasn't really been a characterization of the problem space or an attempt to document, even kind of partially, what sort of use cases real developers are actually doing with it. Now, if we consider a long-term goal of our work was to develop new visualizations in the tracing space, understanding the full problem space was pretty fundamental. And as a result of this conversation, last year we carried out a survey of systems literature more broadly, and we found that visualization was pretty poorly presented in systems literature in general. What this practically means is that not only is it rare to see user interfaces or tools presented in systems literature, but even when it is presented, it's kind of lacking an explanation or motivation. And we saw that this problem was particularly prevalent in distributed tracing. As a result, we decided to try to contribute to this kind of ground setting or characterizing work for viz research in distributed tracing and decided to carry out an interview study with some real practitioners. So I'm going to talk very briefly about the participants and interviews in the study, and then the bulk of the presentation will address the outcomes of the study. So we recruited people directly working with tracing from two large internet companies. And we recruited one person from each company from the following three categories. So first of all, we had front-end developers. This is someone who would be directly working on the implementation or maintenance of the front-end UI of the tracing tools being used at their company. Next, we had a full-stack developer. So this was someone who's not only got a bit of a hand in the front end, but they're also familiar with some of the back-end aspects, such as the trace collection and processing. And finally, we had this third class of consumer. And this is a kind of software developer or data analyst who is exclusively working with the tools and they're not involved in the maintenance at all. And it's important to add that the front end and the full stack developers are also consumers as well as their other roles. We were fortunate that, we were fortunate that two of our participants, whilst working on these bespoke solutions at their respective companies, were actually also active maintainers of some of the widest used open source solutions. So with these participants, we carried out 2 rounds of interviews with the participants, and this included observation of their typical workflows. Then we transcribed these interviews and performed some open coding to extract salient ideas and themes from the interviews. This ultimately led towards the first contribution of this project, which was a characterization of the problem space. And this featured a list of different types of users, typical use cases, and existing problems and opportunities that exist in the field of distributed tracing. We then took this characterization that we had formed and combined it with further observation of existing solutions as well as GitHub issues for open source solutions, and we carried out a further round of coding to identify 5 key challenges which were effectively areas for improvement. We actually iterated on this as a group several times before we reached this stable selection, and we then distilled these 5 challenges into 8 design guidelines to try and address these areas. In addition to these 8 design guidelines, we also extracted several more general open problems which have an impact that's kind of wider than just distributed tracing. So the rest of this presentation, I'm going to focus on a subset of the challenges and design guidelines that we ultimately derived, as well as touching on some of the more general open problems. So ultimately we uncovered 5 challenges, and you can see them each here. Now if any of these sound particularly interesting, I'd recommend reading the paper or talking to me afterwards. However, today, in the interest of time, I'm just going to focus on probably the 2 most pertinent and interesting challenges of mismatched workflow and data quality. And in a moment, we'll come back to see the guidelines. So first, here's this problem with mismatched workflow. So we found that rather than individual trace view being the sole focus of analysis, it's instead kind of one piece of a larger troubleshooting workflow, and users utilized it as part of a bigger ecosystem of analysis tools. For example, users would often flip between their tools for querying the large datasets, such as Presto and other in-house aggregate metrics, as well as using their own ad hoc analyses in things like Jupyter. Now, the biggest problem we saw on this front is that there's no automated interaction between the existing tools. And these arrows you see here, the white arrows, these represent manual switches which rely on a user. And this is summed up nicely in this quote that really kind of emphasizes the importance of individual trace view in perspective. So we're really relying on these other tools to discover the trace in the first place. And secondly is this challenge of data quality. So primarily 2 data quality issues that users would run into. Firstly is this idea of edge case traces, mainly those that are very large. And in some situations, users would actually experience situations where the traces were so large that the UI couldn't even open the trace. And others, there's just like no way of being able to efficiently navigate the huge amounts of repeating data that they encountered. And the second data quality issue concerning traces was those featuring malformed data. So the underlying trace collection systems aren't perfect, and whilst dropping the data is rare, it does actually happen. And both of our examples here are talking about how the UI doesn't make the malformed nature of this data clear, and so there's no easy way for the user to ascertain it. As a result, this means they must often simply kind of throw away the trace and start again. And this is a really big problem because if a request is an outlier, then its trace data is also likely to be an outlier. For example, if you have a long running request, it's naturally going to lead to a very large trace, and the current tooling doesn't allow users to investigate this. So in response to these 5 challenges, we derived 8 guidelines, and we believe these can be applied to greatly improve the impact of distributed tracing visualizations. Now, each of these guidelines was designed to complement one or more of the outlined challenges. So if we consider the 2 challenges that we looked at more closely, our guideline 8 for handling data quality, our guideline 8 for handling edge cases gratefully is primarily designed to address the data quality challenge. Now for challenge 1, the first 5 guidelines all help to address different aspects of this challenge. The other challenges we didn't focus on are similarly served by this complex interaction between guidelines and challenges. And this is, we go into this in a lot more detail in sections 6 and 7 of our paper, so I'd really encourage people who are interested in that to go and have a look. So today I'm just going to focus on guidelines 6 and 8, as they provide some of the more interesting angles for visualization research input. And whilst you can see that this isn't actually explicitly linked to the challenge 1 that we talked about, This is actually there's actually still like a lot of overlap between these challenges, and again, this is kind of explored a bit more in depth in the paper. And it's because like a lot of these challenges are very closely related to each other. So we move on now, look at guideline 6. We're looking here at the concept of aggregate context. As we repeatedly saw, individual traces on their own don't offer significant insights. So we're proposing that where possible, developers should integrate aggregate data into the single trace view. Now for an example of what the problem looks like again, so in this trace, looking at individual span, we can see the latency here is about 300 milliseconds, but do we know if that is good or bad? Is that a slow or a fast span? If we could incorporate aggregate data into this view in some way, this would greatly reduce the reliance on the user's mental model to understand all of the context or infer it, and it can help to reduce the number of mental context switches that a user is required to do. This also helps to reduce the barrier to entry for new users. So now if we look at the principle of handling edge cases gracefully, users frequently encounter these kind of large traces of malformed ones, and any future work really should be able to successfully render these kinds of traces. I'll touch on one potential approach shortly for displaying large traces, and if we think about addressing malformed data, this might require further support from collection systems to flag dropped or corrupted data. UIs can then at the very least indicate that there is a problem rather than relying on a user to discern this for themselves. The biggest problem this principle aims to address is that existing UIs are kind of designed for this golden case of perfect manageably sized data, and we've seen that this is just not really the reality, and that edge case analysis is fundamental to practitioners' analyses. So just to remind you about the overall structure of this project, we conducted an interview study with 6 participants from 2 major web companies, and I spent some time introducing you to 2 of the key ongoing challenges in the area and 2 of our proposed guidelines for future biz work in this space. In the last few minutes here, I'm going to talk about some of the open problems. That's what we just talked about, and now I'm going to spend the last few minutes talking about some of the open problems and opportunities that exist for research in this domain. So our interview study work opens up a wide variety of potential further future work directions with 3 kind of overarching potential directions. So outside of visualization, there's significant potential work around the idea of interlinking tools, developing kind of better infrastructure for diverse and changing ecosystems of tools. Then within distributed tracing, there are many visualization approaches that could ultimately lead to increasing the value of distributed tracing analysis by empowering the users of these tools a bit more. And these visualization approaches also have the potential to feed into larger visualization topics, most notably those involving large-scale data visualization and graph visualization. And with that in mind, I'll briefly look at one potential direction for future work, and this is visualizing large traces. So as we saw earlier, visualizing large traces sometimes breaks existing solutions completely, and other times the data displayed is so difficult to navigate it's effectively useless. We want to take inspiration from existing visualization approaches such as table lens, which is an approach for visualizing extremely large table data, and scalable insets, which is an approach for showing areas of maps at different levels of zoom without actually removing them from their context. So this is what visualizing a large trace currently looks like, where your user has to scroll repeatedly to find relevant information, and there are no convenient ways to interact with the data on this scale. So we hope that by using some kind of focus and context approaches, we can envision an approach that might look something like this, where a user is trying to drill down into a section of the trace exploratively, so maybe they've decided that this area of the trace that I've highlighted is particularly interesting, and we want to try to find a way to display that on the screen as much of the trace as possible on one screen and not lose the general context. So that's the kind of approach we've done here. This is just a kind of a mock-up from some of our work so far. Now this also raises some interesting challenges in this area, including how a user is going to actually interact with traces on this scale, because this is something they don't and can't currently do. And it's also important to consider how can we offer customization and interaction recording in line with some of the other guidelines, which are, again, touched on more in the paper. And additionally, there are these kind of data processing and visualization problems again to address, and this is so when we're displaying traces consisting of thousands of spans, how can we actually do this? And maybe this could even lead to new representations of traces, such as combining spans together visually. So that brings me to the end of the presentation, and to briefly summarize, so users are really important in distributed tracing. And although literature has acknowledged this, there's been no kind of in-depth consideration of users' needs or use cases when designing the user-facing output. And we found that existing tools kind of routinely fail to satisfy users' required needs. So through our work, we've offered the first characterization of the problem area of distributed tracing. We've outlined some existing challenges that users face, and we've proposed 8 concrete design guidelines for future developers of distributed tracing analysis. In particular, we're trying to stress this idea that the diverse nature of the analysis should be accommodated by facilitating customization and designing flexible visualizations that do not assume perfect data. We've already begun to work towards some novel visualizations approaches in distributed tracing, and believe that ultimately our work could lead to more effective tracing analysis as well as contributions to broader visualization research areas. And so hopefully all this will allow our familiar conversation to progress a little bit differently in the future. Thank you very much for listening.